Hi, I'm Maddie, and today I'm going to be talking about doing stoichiometry using molarity. So the problem we're given is, one industrial method to peel potatoes is to soak them in NaOH and then spray off the peel. What is the molarity of the NaOH solution used if 49.3 milliliters of 0.500 molar H2SO4 is required to neutralize 20.0 milliliters of the NaOH? And then it gives us our balanced chemical equation. So, using that, thank you. Okay, good. So using that information that we're given, we're going to set up a fence. So up here is our balanced chemical equation, and then right here is the equation for molarity. So molarity is moles per liter, which is important for this because we're going to manipulate this equation to help us find the answer that we're looking for, which is the molarity of NaOH. So we're going to start with the milliliters of H2SO4, which is one of the values that we're given. So 49.3 milliliters of H2SO4. Okay, and then so when you're doing molarity calculations, the values that you use are very important. So it has to be liters, it can't be milliliters. So the first step that we have to do to solve this problem is take it from milliliters into liters. So in our fence, it's 1 liter over 1,000 milliliters. And so that's going to cancel out the milliliters and make it a liter. And so now we're ready to use the given molarity that we were given for H2SO4, the 0.500 molar. And so what 0.500 molar means is that it's 0.500 moles per 1 liter. And so when we write it that way, we'll cancel out the liter from here because with the 1 liter on the bottom, and it still means molarity. It still means the same thing. So 0.500 moles of H2SO4 per 1 liter. So then we've canceled out the liters, and now we have a mole value. So and this is a mole value of H2SO4, but in order to find the molarity of NaOH, we need to find the number of moles of NaOH. So then we're going to go back to the chemical equation, and we're going to look at the mole ratio between NaOH and H2SO4. So H2SO4 is on top, so we need to cancel it out, so it has to go on the bottom. So there's 1 mole of that. And then there's 2 moles of NaOH, so then we'll put that as well. And so then this is the whole fence that's been set up, and then you're just going to plug and chug. So you divide, and then you multiply, and then you multiply again. And then the answer you get from that is the number of moles of NaOH, which turns out to be 0.0493 moles of NaOH. So now that we have the answer to our fence, we have to go back to the problem and see what the answer to the problem actually is to make sure we're answering the question. So the question is asking for the molarity of the NaOH, and right now we only have moles. So the final step in the problem is to use the milliliter information that we were given about the NaOH and turn that into a molarity. So the molarity would equal I keep writing that wrong, 0.0493 moles over, so in the problem they give us 20 milliliters, so we have to convert that to liters by dividing by 1,000, so that would be 0.02 liters. And then you divide that and you get a molarity of 2.47. And that's with 3 sig digs because that's what we were given with the molarity value and the milliliter value. So that is the answer.